All right. Hey guys, it's Miss Leslie and Miss Markert, and we are here for day 22. Today we are going to review the content that we covered on week 2 of this unit, which is series and partial sum. This is the checkpoint that you guys have done the worst on so far. So hopefully going back over this material and practicing the homework tonight, I will also put the checkpoint up in the homework section, just like I did with the week 1 check. You guys can look over that and practice it. But yeah, so this was, like I said, this is the week that you guys did the worst on. Not that it was that bad, but hopefully after going over it, it will clear up a couple issues for you guys. And then this week on the checkpoint, you'll get these questions right. All right, Ms. Markert, it is all you.
Yeah, so today's going to be similar to yesterday, just kind of structure-wise. I'm just going to kind of hit the highlights. Remember that all the notes are up in the OneNote, so if you want to review something more in-depth, they are all up there. I am just kind of hitting the highlights, and then I'm going to talk about the homework. I don't think I'm going to do any, but I'll talk about it and kind of show you guys what's on the homework, and then that will be it for the day. So let's get started. So we are talking about series today, and again, this was week 2 material. So just as a quick recap of what a series is, this is the sum of terms in a sequence. And remember, we have a special notation for this because, like always, there's special notation for everything in math. And remember, it's this kind of funky looking, it's called sigma. It just means it's our summation. It just is to symbolize that you're adding up everything. Because remember, we have the sum of terms you're adding. And then this is just n equals 1, and this is an. So remember that an is just the explicit equation of whatever series you're working with, whether that be arithmetic, geometric, whichever. Your explicit equation goes here. N is your start term. And in the top here is your end term. There we go. So yeah, that's basically what a series is. It's very similar to a sequence. We just have the special notation, and you're adding up all the terms in the sequence. Okay, so the next thing that we talked about was partial sums of sequences. And this means that you are adding up a specified amount of terms in a sequence. And so if you have say you have the even numbers, then you would add up like the first 5 of the even numbers, and that would be the partial sum, or the 5th partial sum of that sequence. So adding up a specified amount of terms in a sequence. Remember that on your calculator, this is math 0, and then you're going to end up with a bunch of boxes, this sigma notation, and then like that, and then you fill out the boxes accordingly. According to the top is your end term, the bottom is your start term, and then explicit equation. One thing to note here is make sure you're using the same variable for the start term and in the explicit equation, otherwise your calculator will get confused. I think when I did this example last time, I was just using x because it's easy. And I know we write n when we're writing these, but x works just, it's just a variable. So x works just fine there. Okay, and then before I get into showing you the equations for partial sum of arithmetic and partial sum of the geometric series, let's just go over what each piece of it is really quick, just like we did yesterday, or for the equations. So we have S sub n, and that is signified partial sum. And then A sub n is the term number. A1, just like yesterday, is the first term. And then n is the number of terms that you want. Just like that. And we mentioned this yesterday, but I'll mention it again. It's really important that you keep all those things straight, because if you get something confused, you might answer a question wrong or something. So make sure that you have all those down. There's a couple from yesterday that didn't carry over into today. I think the only one is a n minus 1. And remember, that just means previous term, but make sure you have all of those straight. Sorry, I got an email. I forgot to close it. So yeah, okay. So our equation for partial sum of an arithmetic series is S sub n equals n over 2, and then a1 plus an, just like that. So remember here, the only kind of funky thing about this one is that a sub n there, that's your explicit equation, and so you have to use your n term, and so you're basically finding whatever an would equal with the n that you're given, and you're putting in that into the equation. So just remember that this is your explicit equation that you're just kind of plugging in here, or you can solve and then put that number in. So say n was 22, you would find a sub 22, and then you could just put that into your equation right there, or you could put in the whole explicit equation with 22 subbed in. Either way works. But just remember that it's important that you have your explicit equation when you're doing partial sums of arithmetic series. Okay, and then we have partial sum of geometric series. So this is S sub n equals a1, 1 minus r to the n, and this is over 1 minus r. And remember, r is just our common ratio of our geometric sequence or series. Oop. I was starting to write what I was telling you guys. There we go. Just like that. Should be pretty straightforward. And then the last thing we're going to talk about really quick is infinite sum of a geometric series. So this is for your geometric series. And this connects back to limits. And this happens when you have a common ratio where its absolute value is less than 1. So to have an infinite sum, you have to have a convergent series. So this would be a convergent geometric series. And what happens here is your limit as n approaches infinity, it would equal a1 over 1 minus r. So essentially what's happening there is your geometric series has a limit, and that equation will help you find that limit. Yeah. Anything to add, Miss Leslie?
Nope, that seems good. Yeah, Miss Marker pretty much covered everything. Remember, guys, when you see series, it's a sum, like you're adding all the terms up. So the only thing I can kind of remember that a lot of students asked when we did series the first time was like if your first number of your sequence is 5 and it's going down each time. So like say the first one is 5 and then 4 and then 3 and then 2, whatever, you're subtracting 1. People would be very confused how your sum was bigger than 5 because that was the first number. But guys, the sum is bigger because you're adding to get to the sum, right? So it's fine if the sum of your sequence or your series value is larger than the first term or your biggest term of your sequence. That's going to happen because you're adding. So that's kind of the main thing here. And a lot of the problems that was on that first checkpoint and will probably be on this checkpoint you can do if you just sit down and write out the number of terms. It's not like we're giving you, so like if we give you like the value of the 8th term, say, or we give you the sum of the first 8 terms, but you don't know that. You just know it's some random sum. Guys, you can always write out your terms of your sequence and then add them up. So remember, you can use some logic if some of this stuff seems confusing. Just another side note, when you're doing arithmetic series and you don't know the a sub nth term, like you don't know that term because you don't know what n is, you will always have to use quadratic formula. So if you're not using quadratic formula to solve that backwards, you're doing the problem incorrectly. So just kind of keep that in mind. Geometric series, if you're trying to find what n is in a geometric series, you're probably going to need to use logarithms. If you're not using your log properties, you're probably not doing the problem correctly. So just be careful when you're doing those work backwards problems. Those were definitely the ones that gave people a hard time on that first checkpoint. And when I put the checkpoint up there today for you guys to look at, it shows you like the breakdown, like how many people got each question correct. That's just how it prints off once people have kind of done the checkpoint. And so you can kind of see like the most missed questions. So I would definitely check those most missed questions out because they'll probably be the ones that I put on your checkpoint this Friday. So just kind of a heads up there. But yeah, I mean, this is everything you guys need. If you have the formulas and you understand like what the parts of the formula are, this should honestly be really simple. Yes, you might have to use quadratic formula, but that's something you guys learned in Algebra 1. I don't feel bad about that. Yeah, you might have to use log properties, but guess what? You learned that in Algebra 2. I don't feel bad about that either. So you have the skills, you just have to make sure you know what each of the pieces stand for. And Ms. Margaret has it written right there for you. S sub n equals, A sub n equals, A1 equals, n equals something, right? So it's really specified right there. So it should hopefully, if you go back and do the extra practice, hopefully this will be not too bad. The unfortunate part is for those of you who are struggling with this is a topic that comes up in calculus a lot. Like there's a whole section of calculus that deals with partial sums and diverging and converging series. So this is a topic that you will see again next year, guaranteed. So it's important that you learn it. And I mean, if it's a little fuzzy, that's okay, because they will obviously go back over it next year, but it gives you this head start if you can kind of understand how these formulas work. Ms. Margaret knows calculus is probably still pretty fresh for her.
Yeah.
But yeah, so you guys are going to be fine. Just practice, practice, practice. Like I said, definitely try those most missed problems from the checkpoint from week 2, because I'm guaranteeing you're probably going to see those same similar questions again in the future.
Even if you take calculus in college, like you're not escaping this. I had a whole quarter of this in calculus. So it was my favorite quarter of calculus, but it was all this stuff.
Definitely.
Yep. Anyways.
All right. Did we want to go over, like, talk through any of the homework ones?
So the only thing, let's see. The homework should be pretty straightforward and should look very similar. I did add a word problem here, but it shouldn't be too bad. There are a couple, not repeats, but a little bit of a repeat from yesterday, just in finding the common difference here. To kind of get you to question 10, but that's okay. And then you're just finding partial sums again. It shouldn't be anything too bad. Make sure here you identify which series you're working with. But yeah, I think that's about it. Shouldn't be too bad.
All right. Well, hopefully this was good review for you guys. Practice. And like I said, definitely try this homework. It doesn't look too challenging. And then check out that checkpoint for week 2. Just so you guys can see where your mistakes were. It was a tough week for some people. But yeah, that's it for today. And we will see you guys again tomorrow with a review of binomial theorem, right?
Mm-hmm.
Yeah.
Yeah.
Okay.